An application wanting a guarantee sends a request path message towards the destination. This message traces the path and alerts routers along the way that a reservation might be coming.
Okay, scouts the route.
Then the receiver, if it wants the flow, sends back a response reserve message along the same path. As this reserve message travels back, each router looks at the request how much bandwidth buffer space is needed and checks if it can actually provide it.
And if can.
If it can, it reserves those resources and forwards the reserve message upstream. If all routers along the path agree and reserve the resources, the application gets its guaranteed service level.
So it's an active negotiation between the application and the network routers.
Very much so.
Yeah.
And our sources mentioned this often works as a trio. You might use RSVP for the initial setup, the reservation. Then the actual real-time data, like video or audio, might be sent using RTP, the real-time transport protocol.
Okay, RTP carries the data.
And alongside RTP, you often have RTCP, the real-time control protocol. RTCP doesn't carry the main data, but it sends control messages back and forth, reporting on the quality of the RTP stream, things like jitter, packet loss, delay.
So it provides feedback.
Exactly. It tells the sender how things are going, allowing the sender maybe to adjust the data rate or encoding to adapt to network conditions and maintain quality.
Wow. RSVP reserves, RTP delivers, RTCP monitors and reports. That's quite a system. Now, you mentioned InServe, earlier integrated services. How does RSVP fit into that picture?
InServe is the broader architectural model that uses RSVP as its primary signaling mechanism for making those end-to-end reservations. The whole philosophy of InServe is reserve resources on every router along the path before you start sending the important data.
Proactive reservation.
Right. And InServe has three key components, really. First, classifying packets to know what service they need. Second, scheduling them appropriately based on the reservation. And third, a really crucial step, admission control.
Admission control, like deciding who gets to make a reservation.
Exactly like that. Before a router agrees to a new RSVP reservation request, it performs admission control. It asks itself, do I actually have enough spare bandwidth, buffer space, and processing power to guarantee the QoS for this new flow without messing up the guarantees I've already made to existing flows?
So it checks its capacity.
Precisely. If it can't handle the new request without potentially compromising other guaranteed flows, it just rejects the request. It won't admit the new flow. There's a similar concept in ATM networks called CAC, Connection Admission Control.
Okay, so InServe is very stateful, very focused on individual flows and strict